So guys, in this video we are going to continue the nucleophilic addition reactions of derivatives of ammonia with your carbonyl compounds. So to begin with, we are using today one of the derivatives of ammonia called as your hydrazine. So first of all, let us see what is the formula of this hydrazine so that it would be easy when we are writing the reactions. Okay. So hydrazine's representation is NH2 single bond NH2. Okay. So we are going to use today this hydrazine as one of the derivatives of your ammonia, and we are going to see that what happens when you treat this hydrazine with your carbonyl compounds. So to begin with, first of all, let us take our aldehydes. So the general representation of our aldehydes is RC double bond O and a H. As I have mentioned earlier, how to write this now, NH2, I will just take one H out. Yes, then remaining will be a NH single bond NH2. As given the sort of explanation yesterday, this reaction will be in equilibrium. First of all, you'll be getting an intermediate. How will be getting? Yes, by utilizing the lone pair of electrons on the oxygen. Of course, what will be happening? This hydrogen will be attracted. So oxygen will be getting a plus sign. Now this pi electrons will be moving towards the oxygen. Carbon will be having the positive sign. Utilizing now nitrogen's electron density high power, it is going to attack our carbonyl carbon. So if I am going to write it directly, I would be getting as RCOH. Yes, here I am having a H completed. Now this much part I have to written. Remember, the bonding is for this nitrogen. So NH and that of your NH2. Yes or no? Now as I mentioned, now in the presence of your acid, we know that this reaction is taking place in the presence of your acids itself. Yake acid beke beku namge one reaction andre, because it easily facilitates the reaction in such a way that through the dehydration of this intermediate we will be getting our final nucleophilic addition product. So of course I have mentioned how does your H2 will be formed now. Of course now this OH minus will go out. OH is going out as OH minus. OH minus and this bond electrons is also taken away by this hydroxide ion. So now on basis what happens, now carbon will be getting a positively charged. So in order to balance that one, what it will do, whatever the lone pair of electrons will be there on the nitrogen atom, that would be given. So in turn now nitrogen will get a positive sign. So this H, whatever the bond is associated between N and H, that will be taken by nitrogen. So H plus will be coming out. So H plus and OH minus gives you the water. So the final expression I would be having as R single bond C single bond H. So this much part. Now C and N is having a double bond character NH2. NH2. You can just note it down. The same way what we have written yesterday, the format is same. So we are having a C double bond N Z. So in the place of Z we are having an NH2 group. Yes or no? An NH2 group is present. And remember, such type of compounds are generally called as hydrazones. They are called as what? Hydrazones. So whenever we are talking about an aldehyde giving a hydrazone, it is called as an aldehyde hydrazone. Or it is called as aldehyde hydrazones. Very much important. Generally they can ask you, how can you prepare hydrazones? Remember, whenever a carbonyl compound is treated with a hydrazine, you will be getting a hydrazones. When they are more particular about asking about how can you prepare aldehyde hydrazones, then of course we have to be more particular. Whatever the carbonyl compound you have to choose should be an aldehyde. So whenever an aldehyde is treated with a hydrazine followed by dehydration, you have to mention the overall line. How you are getting the hydrazones? Whenever an carbonyl compounds are treated with a hydrazine followed by dehydration, you will be getting your aldehyde or respective hydrazones. Is that clear? So as we are getting the part C double bond NZ, you are knowing alwa that was a general representation of whatever the nucleophilic addition product we were writing for our ammonia and its derivatives. In this case, there is a hydrazine. We are having the Z as NH2. Is that clear? Now coming with respect to the ketones, R, C, double bond, O and R. So treating this one with your hydrazine, NH, NH2. Remember, the reaction will be in equilibrium. Yes. So of course now what will be happening? The same way, RCOH. Of course one R is there. Instead of this H, now we are having an R in terms of ketones we are writing. Then here you'll be having as an NH, NH2. So of course we know water has to be dehydrated. So OH is going out. Carbon will be getting a positive charge. So in order to balance that positive, nitrogen will be giving its lone pair of electrons. In turn, now nitrogen will be having a positive charge. In turn, to balance that positive charge, this electrons will be moved towards your nitrogen. So what will be happening? You will be getting as RCR. Yes, this part. Then with respect to C and the N, we are having a double bond character. So double bond N can write. Yes or no? Then what else is remaining? NH2. NH2. You can just check out the valencies of nitrogen. Only 3 are there. 3 bonds, 3 valencies. NH3 ಅಂತ ಬರೀತೀವಲ್ವಾ, NH4 ಅಂತ ಬಂದಾಗ ಪ್ಲಸ್ ಬಂದ್ಬಿಡುತ್ತೆ ಮುಂದೆ ಎಕ್ಸ್ಟ್ರಾ ಇದ್ದಾಗ. ಇಲ್ಲಿ ಯಾವ ತರದ ಪ್ಲಸ್ ನೆಗೆಟಿವ್ ಇಲ್ಲ ನಮಗೆ. ಡೈರೆಕ್ಟ್ಲಿ we are getting as what? C double bond N NH2. So what this will be called as more particularly ketone hydrazones. Ketone hydrazones, very much important reactions. Many times they can ask you, how can you obtain hydrazones? So you have to remember, whenever a carbonyl compounds are treated with hydrazine, the major important reactant is our hydrazine. See the formula of hydrazine, NH2 single bond NH2. See the way I have written, ಈ ತರ ನಾವು ಎಲ್ಲದಕ್ಕೂ ನಾವು ಫಾಲೋ ಮಾಡ್ತಾ ಬಂದಿದೀವಲ್ವಾ. Till now whatever we have seen, it may be your ammonia, we took it as a H NH2. It was in case of your amines, we took it as H NHR. Then when it was a case of a hydroxylamine, we took it as an HNHOH. Why we are making it like that? Because you can only see when I am writing this H out, easily I can carry out my reaction, and easier way to understand these reactions. Okay. So this was with respect to the hydrazine. So whenever a carbonyl compounds are treated with a hydrazine followed by a dehydration, remember, we will be getting your respective hydrazones. What we are getting? Hydrazones. Please remember this product's name. Is that clear? So when we were treating with an ammonia, we get an imine. Yes. So when we were treating with an amines, we got a skiff base. Yes. So when we were treating with a hydroxylamine, we got an oximes. So now when we are treating with the hydrazines, we are getting what? Hydrazones. Is that clear? This is also one of the derivatives of your ammonia. Coming to the next important derivatives, is similar to that one, but the slight modification we are going to do, which is called as phenyl hydrazine. Phenyl hydrazine. Phenyl hydrazine. Please look after now whatever we had done. Of course, here we have seen hydrazine. Here we are adding a phenyl hydrazine. You will be just aware of its formula. So NH2. Yes, NH2 is there. Now what I am going to do is, one H will be replaced by your phenyl group. Is that clear? So how we will be having the formula? NHC6H5. So NH2 NHC6H5 is called as what? Phenyl hydrazine. I repeat, how we are writing NH2 NHC6H5. That's a major difference. The same formula, but one of the hydrogen is replaced by that of your phenyl group. So hence the name phenyl hydrazine. Phenyl hydrazine. So let us look after. Remember here also, I'm going to write the same way how I have written over here. Not a great change. Just the character is, whatever the product you are going to get, it mainly depends upon what is that Z. Yeah. So first let us carry out our reaction with aldehydes. So how can I write RC double bond O and a H? Yes. As I have mentioned, just write ಯಾವುದು ತುಂಬಾನೇ ಈಸಿಲಿ ಅವೈಲೇಬಲ್ ಪ್ರೋಟಾನ್ ಇರುತ್ತೆ ಅದನ್ನೇ ಬರ್ಕೋಬಹುದು. ನೀವು ಕೇಳಬಹುದು, ಸರ್ ನಾವು ಈ H ಯಾಕೆ ತಗೊಳಕ್ಕಾಗಲ್ಲ? ಇಟ್ ಇಸ್ ನಾಟ್ ಸೊ ಈಸಿ ಟು ರಿಮೂವ್ ಆಗ ಕಷ್ಟ. ಇಟ್ ಇಸ್ ಈಸಿಲಿ ಅವೈಲೇಬಲ್. ಸೊ ಐ ವಿಲ್ ಬಿ ರೈಟಿಂಗ್ ದಿಸ್ H now. H NH NH C6H5. So no. So now as usual, first reaction will be in equilibrium. So as we have said, by utilizing this pi electrons, it is attracting your H plus, and in turn oxygen will be having satisfy agutte plus positive charge. Our carbon mele positive charge barta untu, so N is going to attack. So what you are going to get? R C OH. Yes, of course it is having the H, but along with that one you also are getting as NH. Yes, and also NHC6H5. As I mentioned now, this OH will be going out as OH minus, carbon will be getting a positive charge, utilizing the lone pair of electrons nitrogen that will be provided over here, forming a C double bond N character. In order to balance now this positive charge, these electrons will be taken towards itself. So H plus and OH minus gives us the water. So minus water, a dehydrating is taking place. So the final product, how can you write? R single bond C single bond H. Then you are having a double bond N. Yes, you can only see now this one, NHC6H5. If I write more particularly clearly, RCH double bond N single bond NHC6H5. So you can just note over there what is the Z we have obtained over here. Remember, they are called as a phenyl hydrazones. So what they are called as? Phenyl hydrazones. So in the same case, hydrazine is the hydrazone aitu, phenyl hydrazine is the phenyl hydrazones aitu. So that is the major difference you have to remember. Okay. Now coming with respect to the another part, that is with respect to the ketones. You can only write, I hope, RC double bond O and R. So when it is treated with your phenyl hydrazine, H, NH, NH, C6, H5. Please note the formulas are very much important. So first of all, it will be in equilibrium. So you'll be getting as RC, OH, R. Then you'll be having as a NH, because this H is there with along with N. Then you'll be having as a NH, C6, H5. So when you're removing the water from over here, so this is going out, this will be provided to the nitrogen, whatever the lone pair of electrons, that will be provided over here. So we'll be getting as a final structure as RC, R, double bond N, single bond NH, C6, H5. So this is called as what? Phenyl hydrazones, but we can generally call them as a aldehyde phenyl hydrazone, ketone phenyl hydrazones. Very much important. So whenever we are treating our phenyl hydrazines with the carbonyl compounds followed by a dehydration, we are getting as hydrazones. Okay, this hydrazones we are having, of course, the Z is over here. You can only notice it is NH C6H5 alva. So this is the value of, or we can say this is the Z when you're talking about phenyl hydrazine. When I am talking about your hydrazine, the Z was what? Just NH2. Yes or no? So this makes the difference. Okay, so we came to know that whenever a carbonyl compounds are treated with your hydrazine, you are getting as a hydrazones. Whenever the same carbonyl compounds are treated with a phenyl hydrazine, we are getting as a phenyl hydrazones. Is that clear? Do remember, all these products are called as what? Nucleophilic addition products. You can only notice over them. Nothing we are replacing, just it is getting added to the carbonyl carbon. So that is the reason it's an addition product. But whatever it is adding is a nucleophile, and hence it has got the name as what? Nucleophilic addition products. Is that clear? So next let us go with the another important derivative. So guys, the next important derivative we are going to see, first of all, you remember its name. It is called as semicarbazide. Semicarbazide. Remember, from hydrazines itself we are going to extract now whatever we are seeing. Hydrazine in the phenyl hydrazine heng bariyadanta nodadvalva. Other riti I will tell you how to write this semicarbazide by using your hydrazine structure itself. So of course hydrazine means what we were doing, we were writing as a NH2 single bond NH2 alva. When it was a phenyl hydrazine, one H was taken out, and instead of that one I have added a C6H5. The same protocol will be followed over here. Of course, first case you will be having your NH2, this NH2 will be there, but now one of the hydrogen will be replaced by an amide group, that is C double bond O NH2. C double bond O NH2. Nothing we have done. Don't get panic over the overall. First you just see that with respect to hydrazine how it is similar. So just one of the hydrogen of your hydrazine has been replaced by your CONH2 group. CONH2 group. So overall this structure is called as what? Semicarbazide. Semicarbazide. Why I am going to you very clearly about this means, if you remember these formulas, easily you can only carry out the reactions and you can only easily write the products. Okay, come with me, let us have a check. So of course if I choose now my aldehyde, RC double bond OH I am using. So now when I am treating this one with my semicarbazide, how can I write it? Of course, I have mentioned first the easily available proton is this part itself, H, NH. So I have taken a H from here. Then as usual, everything else is same, NH, C double bond O, NH2. See, simple things we are writing the same way. So you'll be getting as an R, C, OH, H. This H has gone. Now this nitrogen is going to attack. So the Fristol part will be same, NH. You write it in this way itself. Then what you do, the remaining part you write it intact. That is NH, C double bond O, NH2. You can write it in this way. It will be easy because this hydrogen is only going out. So now when it is undergoing a dehydration, that is negative water minus water. So OH is going as a OH minus. Of course, as I mentioned, lone pair of electrons will be coming over here in order to balance that positive charge on nitrogen. This electrons will be pulled. So H is going out as H plus. So H plus and OH minus gives you water. To write it more particularly, I can just write it over here, minus H2O instead of writing over here. So you can write it as an R, single bond C, single bond H. I have completed this part. Now C and the N is having a double bond character, double bond N. H is not there, it has gone out. The remaining part is N, H, C double bond O, NH2. You can only note it down, alva. So these are called as semicarbazones. Semicarbazones. So from semicarbazide, we are getting as what? Semicarbazones. You can only see now C double bond NZ format itself. In the place of Z, we are having NHCO, NH2. Yes or no? So what are called? They are called as generally semicarbazones. Very much important. You have to remember those names. Okay. Similarly, if you choose ketones, help me out. So R, C double bond O, R. Of course, how will you write your semicarbazide? Don't see up. You can only note first NH2 you have to write. Okay, first I will write as a H. So NH2 single bond NH. Then the amide group CO NH2. Alva. So the same way it goes. First reaction will be in equilibrium. Note my arrows. Then you'll be getting as an RCOH and a R. Remaining part is over here NH. So you'll be having as an NH, C double bond O and a NH2. Yes or no? So this will be the format. So now OH is going out. So this will be given, this will be taken. So you'll be having the final product. We'll write it over here by the dehydration. We'll be getting as R. Yes. Then we'll be having as what? CR double bond N single bond NH C double bond O NH2. So this is called as what? Once again, semicarbazones. Semicarbazones. Of course, aldehyde semicarbazone, ketone semicarbazones. But important thing what we have to remember is whenever our carbonyl compounds are treated with a semicarbazide, followed by dehydration, we will be getting as a respective important nucleophilic addition product called as semicarbazones. I repeat, semicarbazones. Is that clear? Coming to another important, the final derivatives of ammonia, okay, which is called as 2,4 DNP. So guys, 2,4 DNP. First of all, you just remember what is the full form of this DNP. Okay, nothing much. So this DNP is called as, for D it stands for di, N stands for nitro. 2,4 positionally 2 nitro groups are there. So dinitro phenyl hydrazine. Phenyl hydrazine. Okay, so DNP full form is what? Dinitro phenyl hydrazine. Okay, one of the most important we can say a reactant, because this can be used as a test for the identification of carbonyl compounds. So this can also be called as Bosch reagent, BORSCH reagent. Okay, this 2,4 DNP can be also called as a Bosch reagent. Why I am saying this in certain cases, in your competitive exams they can ask you, even in your PU exams also they can ask you, give an reaction when a carbonyl compounds are treated with a Bosch reagent. So don't get panic. Bosch reagent is nothing but that of your dinitrophenyl hydrazine. So it's called as apostrophe S. Bosch reagent. Bosch, BORSCH apostrophe S reagent. Nothing but your dinitrophenyl hydrazine. So what is the main, first of all we have to see alpha how to write this reactant. Of course hydrazine is there, so that is the important case we know. So NH2 will be there as usual. Now what you have to do, just note over here, one of the H of your hydrazine will be now replaced by 2,4 dinitrophenyl. So this is my phenyl, yes or no? So NO2, 1, 2, 3, 4, NO2. So with respect to this compound, this group we are having in the second position nitro group, in the fourth position nitro group. So nothing we have done. So in hydrazine we got, similarly with respect to that of your phenyl hydrazine also we got. How we are writing, just we have to take a H replace ಮಾಡ್ತಾ ಬರಬೇಕು ಯಾವ್ದಾದ್ರು ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಗ್ರೂಪ್ ಇಂದ. ಫಿನೈಲ್ ಹೈಡ್ರೋಜನ್ ಅಲ್ಲಿ ಫಿನೈಲ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ವಿ, ಸೆಮಿಕಾರ್ಬಾಕ್ಸೈಲ್ ಅಮೈಡ್ ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ವಿ. ಅದೇ ರೀತಿ ಈಗ DNP ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು, 2,4 DNP ನ substitute ಮಾಡ್ತೀನಿ. Thus if you remember this part, you can easily carry out your reaction. You can only see 2,4 dinitrophenyl, rest over here hydrazine. Okay, so now let us check out what you're going to get when you treat this one with the aldehydes. Don't get panic. You can only see the reaction ಎಷ್ಟು ಸಿಂಪಲ್ ಉಂಟು. ನಾವು ಏನೇನು ಚೇಂಜ್ ಮಾಡ್ತಾ ಇದ್ವಿ ನಮಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಇರೋದು ಬರೀ ಇಷ್ಟಲೇ. ಇದರಿಂದಾನೇ ಎಲ್ಲದೂ ಹೋಗ್ತಾ ಉಂಟೇವಿನ ಇದರಿಂದ ನಮ್ಗೆ ಯಾವ ತರದ ಸಿಸ್ಟಮ್ ಅರೈಸ್ ಆಗ್ತದೆ, ನೀವೆಲ್ಲ ಕಡೆ ನೋಡ್ಬೋದು. ಇಲ್ಲೂ ಕೂಡ ನಮ್ಗೆ ಇದರಿಂದಾನೇ ಹೋಗಿದೆ ವಿನ this part is getting intact. This part is getting intact. In all the cases, it may be amines, it could be a hydroxylamine. So whatever the additional group you are adding, that will remain there itself. So there is not a great task. Just it will look bulk. It will look bulk, of course, but don't get panic with this bulkiness. The reactions are very much simple and is following the same procedure in all the cases. Yes or no? So when I am talking about now aldehydes, how can I write? RC double bond O and a H. So treat this one with now H, take out one hydrogen which is easily available, H and H. I have to count one hydrogen from this type, then remaining as it is NH, then you will be getting as your 2,4 DNP. Yeah, the same way you just write it. Yes, so first will be in equilibrium. So what will be getting, RCOH and a H. So remaining of this N should attack, so NH, and as usual NH, then here comes your NO2, here comes my NO2. So finally by dehydration, that is by removing the water from this intermediate, this is going out, the utilizing the lone pair, so now this will be coming over here. So the final product RCH, yes, double bond N, you can just see the Z now what it will be, NH, 2,4 and the phenyl, 2, 3, 4 NO2. Are you able to see? So these are called as what? 2,4 dinitrophenyl hydrazones. 2,4 dinitrophenyl hydrazones. Phenyl hydrazones. You can remember the names, I hope. So 2,4 dinitrophenyl hydrazine, when it is treated with your carbonyl compounds followed by a dehydration, we are getting an important addition product which is called as 2,4 dinitrophenyl hydrazones. Okay, you can only try it with now ketones. Nothing much changes, just in the presence of this H we will be having one more R group. So just write H, NH, single bond NH. So here is your NO2 and here is your NO2. First they will be in equilibrium. So first part you just write as a RCOH and a R. So here you'll be getting as a NH. So here of course now NH. So the phenyl ring with two positions at NO2 and an NO2. Yes, as usual, OH is going out, this will be coming, this will be coming over here. The final structure followed by a dehydration, that is by removing the water molecules, we are having as an RCR. Yes, RCR. Then between C and nitrogen we are having a double bond character, then rest all is NH. Then you will be having your 2,4 dinitrophenyl. So this is also called as what? 2,4 completely dinitrophenyl hydrazones. Phenyl hydrazones. Is that clear? So I have mentioned you earlier when I was doing this reaction, what was that? So this can be a test for the identification of your carbonyl compounds. Of course, why is it so? I said because remember, whatever this 2,4 dinitrophenyl hydrazones you are going to get, it is only when you are treating your 2,4 dinitrophenyl hydrazine with carbonyl compounds. So this, whatever the product you are going to get, it will be having a specific color of orange yellow. So this 2,4 dinitrophenyl hydrazones is actually having a color of orange, very bright orange crystalline type of nimge form agutte, which says that whatever the compound given to you was a carbonyl compound. I repeat, so whenever your carbonyl compounds are treated with a 2,4 DNP, that is dinitrophenyl hydrazine, so they will be going to give you these 2,4 dinitrophenyl hydrazones, whatever it may be your ketones or Aldehydes, whatever. But what it is giving, when this product is formed, that is your hydrazones, when it is formed, 2,4 dinitrophenyl hydrazones, they will be having a specific color of bright orange crystalline. Okay, they will be crystalline, bright orange color you will be getting. So by that appearance of the color, which can be used as an observation, which can be said that whatever the compound given to you was the carbonyl compounds. Is that clear? So that is the reason I have mentioned that this test can be used as a test of the identification of your carbonyl groups. Is that clear? So now let's have a quick revision of whatever we have dealt so far. So generally I will be saying in words. Okay, so we came to know that whenever the carbonyl compounds, I will just write it in this way, whenever the carbonyl compounds were treated with, first of all was your ammonia, that is your NH3, yes, followed by your dehydration, I'm writing the final products. Remember, first of all we got as an imines. You just know by yourself what will be the Z. In all the cases, this Z is only going to vary. Then the same carbonyl compounds, when it was treated with your, we can say amines, that is your RNH2. Of course, we have got what? Schiff's base. Remember, whatever the final product I am writing, it is soon after the dehydration of our intermediate. I am just giving you the hint how to remember these part. Similarly, when the carbonyl compounds were treated with hydroxylamine, that is NH2OH. So what you got here, generally it was called as an oximes. It was an aldehyde, it was called as an aldoxime. If it was a ketone, it was called as a ketooxime. Yes. Similarly, now when I am talking about my carbonyl compounds treated with hydrazine, here somewhat changes we have seen. NH2, the structures part. Illi ಏನು ಪ್ರಾಬ್ಲಮ್, ಇಲ್ಲಿ ನಾವೆಲ್ಲ ಡಿರೈವೇಟಿವ್ಸ್ಗೂ ಇಲ್ಲಿ ಒಂದು H ನ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಬಂದ್ವಿ. NH3 ಇಲ್ಲಿ ಒಂದು H ತೆಗ್ದು R ಹಾಕಿದ್ವಿ, ಇಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ ಅದೇ H ನ ತೆಗ್ದು OH ಹಾಕಿದ್ವಿ. Now whatever the structures we are going to see, we are going to extract the remaining structures by using this structure of hydrazine. But remember, this hydrazine is also derivative of ammonia itself. Yes, nothing much we have done. NH2 ಈ ಒಂದು H ತೆಗ್ದು ಏನ್ ಮಾಡಿದ್ವಿ NH2 ನ ಆಡ್ ಮಾಡಿ. So it is a derivative of ammonia. But now next whatever we are going to see, I will just use this part itself. For that, it will be better for us to understand easily how to remember those structures. So what you got here was an hydrazones. Alva, for hydrazones we have obtained. Similarly, when the carbonyl compounds were treated with phenyl hydrazine. So what did I do? NH2, NH, C6, H5. So here what you got? You got over here as a phenyl hydrazones. Phenyl hydrazones. You just see hydrazine idu hydrazones. Phenyl hydrazine idu hydrazones. So that's where you have to remember. Similarly, when the carbonyl compounds were treated with the next word, what we saw was semicarbazide. How to write it? NH2, NH. Then remember C double bond O NH2. So this was called as semicarbazide. It's only through the practice you'll get to know how to remember these formulas. Okay, it is not you can only see how easy they are. You know each and everything. Just you have to recall, and you have to, by practice, you can easily follow their structures. So you will be getting as what? Semicarbazones. You're going to get as what? Semicarbazones. I'm not writing the structures for this one because I want you to remember their names. Of course, you can easily write their structures just by replacing this Z, and if you know the reaction. but the names are very much important. Similarly, when you treat your C carbonyl compound with that of your Bosch reagent, BORSCH''S. So what is this Bosch reagent? Remember, don't get confused. 2,4-dinitrophenyl hydrazine. It is not hydrazone, it is hydrazine. It's called as a Bosch reagent. So whatever you're going to get, it is called as what? 2,4-dinitrophenyl hydrazones. Dinitrophenyl hydrazones. So this test can be a test of, we can say, identification of your carbonyl compounds, because whatever the 2,4-dinitrophenyl hydrazones you're going to get, it will be having an orange color, okay, which can be used as a test for the identification of carbonyl compounds. Very much important, because in this second PUC you will be having a viva with respect to the functional group organic functional group identification test. So there is also one test about this 2,4 DNP. There once again you will be seeing, but it is good if you remember this when we are reading about it. So remember, this 2,4 DNP test is a test for the identification of our carbonyl compounds. Why? Because whatever the 2,4 dinitrophenyl hydrazones you're going to get, it is having a specific color of orange color. It is only obtained when this 2,4 DNP is treated with carbonyl compounds. Is that clear? So this was a quite, we can say, a quick revision part of whatever we have dealt with respect to the two important videos, that is your nucleophilic addition reactions of ammonia and its derivatives with carbonyl compounds. So guys, it's just an important chart. Okay, this I'm using it for the better understanding, because whatever we have dealt in our reactions so far, I just took about the general reactions. I've just chosen as R. But when the question arises whether the R is having certain groups, here they have given a certain important R. That is one case it was a formaldehyde if you are using, because when I was talking about aldehyde, I just took it as a RCH. What happens if there is an R is having a substitution as H? So that will be giving us a HCH. So that will be acting as a formaldehyde. In all the cases, I just want to just signify their names. Nothing much difference. Whatever we have added, they are just adding with that name the respective aldehydes and ketones. Let's look after. So first reagent, what they are treating your formaldehyde with hydrogen cyanide. Of course, what we know, whenever an aldehyde is treated with a hydrogen cyanide, it is called as what? Cyanohydrin. But as soon as we are treating a formaldehyde, they are giving a name of an aldehyde. The product name will be called as what? Formaldehyde cyanohydrin. Similarly, when this formaldehyde is treated with sodium bisulfite, of course we know we are going to get an addition product which is also called as what? Bisulfite. So when it is a formaldehyde, the final product will be called as what? Formaldehyde bisulfite. Similarly, formaldehyde, when it's treated with a hydroxylamide, what you know, you're going to get an oximes. So when it is an formaldehyde, we are going to get as formaldoxime. Formaldoxime. Similarly, with the hydrazine, what we have seen, we are going to get hydrazones. When it is a formaldehyde, it is formaldehyde hydrazone. Coming with phenyl hydrazine, it is formaldehyde phenyl hydrazone. When formaldehyde is treated with a semicarbazide, it is called as a formaldehyde semicarbazones. Just they are utilizing the name of the whatever the aldehydes you have used. I'm just saying that in case if they are giving you any particular aldehydes or ketones, you can easily write their names. But the main thing what we know, knowing its names, final addition product in a names go to. If they are giving you particular aldehydes and ketones, just you have to write off those aldehydes and ketones name followed by the name what we have extracted. Okay. Coming with the next reagent is your acetaldehyde. Acetaldehyde is nothing which is called as an ethanol in IUPAC name. As I mentioned, most of the cases, instead of using the IUPAC name, we use the common names itself in aldehydes and ketones. So acetaldehyde, when it's treated with the hydrogen cyanide, we are going to get an acetaldehyde cyanohydrin. When it is treated with the sodium bisulfite, we are getting as an acetaldehyde bisulfite. Acetaldehyde, when it's treated with the hydroxylamine, we are getting as an acetaldoxime. Similarly, acetaldehyde is treated with the hydrazine, we are getting as an acetaldehyde hydrazone. When the acetaldehyde is treated with the phenyl hydrazine, we are getting as an acetaldehyde phenyl hydrazone. Acetaldehyde is treated with the semicarbazide, we are getting as acetaldehyde semicarbazones. Nothing much difference, alva. Similarly, when you took benzaldehyde, that is your C6H5CHO, where your R has been substituted with the phenyl group. First, with the HCN, you are getting as a benzaldehyde cyanohydrin. You can only say now, benzaldehyde when it's treated with the sodium bisulfite, benzaldehyde bisulfite. when benzaldehyde is treated with a hydroxylamide, what you can say, benzaldoxime. Yes, benzaldoxime. Similarly, when your benzaldehyde is treated with a hydrazine, what you can say, benzaldehyde hydrazones. When your benzaldehyde is treated with a phenylhydrazine, or it will be called as benzaldehyde phenylhydrazones. Similarly, when benzaldehyde is treated with a semicarbazide, it is called as benzaldehyde semicarbazones. Similarly, in the case of acetone, when it is treated with HCN, it is called as an acetone cyanohydrin. Similarly, when acetone is treated with a sodium bisulfite, you are getting it as an acetone bisulfite. When acetone is treated with a hydroxylamine, we are getting it as an acetoxime. When acetone is treated with a hydrazine, we are getting as acetone hydrazone. Acetone, when treated with a phenylhydrazine, we are getting as acetone phenylhydrazone. When the acetone is treated with a semicarbazide, we are getting as acetone semicarbazone. Coming with respect to acetophenone. Acetophenone, that is what is the formula? C6H5COCH3. Yes. So remember acetophenone cyanohydrin. But remember, with case of your sodium bisulfite, we are not getting any product. What is the reason? Yes, because of its bulkiness, the reaction is not favored. Yes, that is the reason we are not getting any product. You can just go back and have a look of the reactions with respect to the sodium bisulfite. There we have mentioned, as the bulkiness is going to increase, the production, the product will not be obtained that much easily. So that is the reason they have left it blank. Remember, acetophenone is not giving any addition product with respect to the sodium bisulfite. But in all the cases, as similar to that we have observed earlier, it is going to give an acetophenoxime when it's treated with the hydroxylamide, acetophenone hydrazone when it's treated with the hydrazine. Similarly, with phenylhydrazine, it is giving you acetophenylhydrazones. Similarly, when you're treating with a semicarbazide, acetophenone semicarbazone. Most important thing, we have to remember these names. That is the reason I have given you these names. If you are remembering these names, easily you can write whatever the compound they are giving to you. Alva, whatever the aldehydes or ketones, just you have to remember those aldehydes and ketones, write their name followed by these names. Is that clear? So in our next video, we are going to see certain important reactions. That is your reduction of carbonyl compounds. Once again, it will be a named reaction. That is the reason. Very much important to know to have a look on those reactions. So this completes of today's video about the addition of, or we can say, nucleophilic addition reactions of your carbonyl compounds.